Lesson 42 is about solving multivariable equations. So what this means is we'll be doing solutions to equations like we've been doing, except these will have more than one variable in them. For example, look at this equation here. 3y plus x plus 2z equals 11. Now, how are you going to solve that? It's a multivariable equation. There's more than one variable in it. So how are you supposed to solve it, and what are you supposed to solve for? Well, in the book, they will always tell you which one of those variables they want you to solve for. So for A, let's just go ahead and solve for y. That's what we'll be solving this equation for. And so that means we need to get y by itself on the left-hand side, and then we will have a solution for it. But it will also have in its solution, it won't just be a single number value, it'll have variables in it as well. We follow our same steps as we always do: addition rule first, then multiplication and division rule. So we look at this and we see that we want the y by itself, but we have a plus x and a plus 2z. So we just subtract x and we subtract 2z from both sides. Okay, so now we can cancel those on the left, and we have 3y is equal to 11 minus x minus 2z. Okay, now we just need to divide both sides by 3, and that will get us to solve for y. And that means the 11, the negative x, and the negative 2z, everything on the other side has to be divided by 3. You can't just divide one number or one term. Everything has to be divided by 3. So the 3's cancel, and we end up with that for our answer: 11 minus x minus 2z over 3. Now we could also write that as individual fractions: 11 thirds minus x over 3 minus 2z over 3. We can do it that way as well. And usually in the answer key and solutions manual, that's how they'll have it. They'll have individual fractions instead of everything over the same fraction or the same denominator. It's important, though, to understand that everything on the right side is divided by that 3. Let's do another one. In this problem, I want you to solve for a. So that means that we need to get a by itself. We can get it on the left-hand side or the right-hand side, but I usually just do them on the left-hand side. Try to isolate the variable and get it on the left-hand side. So what we need to do here then is we need to subtract an a from both sides, and we also need to subtract a 2b and a 7 from both sides. So now let's just go back through here and cancel where we can. That a over a will cancel, this 2b over b, and this 7 over 7 will cancel. And so we end up with 3a minus a is 2a equals a negative 5 and a negative 7. That's a negative 12. And a b and a minus 2b, that's a negative b. Okay, so now we can just divide both sides by 2. Divide everything on the right side by 2. Not just one term, or this, not just the first one or just the second one. And then we'll end up with a is equal to minus 12 over 2 is negative 6, and then minus b over 2. And so we can leave our answer like that. Let's go ahead and do one more. In C, we have x plus 3y is equal to 14 minus 2x. I want you to solve for x in this one. They'll always tell you which variable to solve for. And maybe you've noticed a lot of these algebra problems, x is the variable in the equation, but don't always automatically solve for x in these equations. Solve for the variable that they ask you to. And so this one we want to solve for x, and so that means we want to get x by itself on the left side. So we would add this 2x to both sides, and then we'd also add a negative 3y to both sides, And so our 2x's on the right cancel, our 3y's on the left cancel, and we'll end up with 3x is equal to 14 minus 3y. Divide everything on both sides by 3. The 3's cancel on the left, and we end up with x is equal to 14 thirds minus y. Now you can change that 14 thirds to 4 2/3 or just leave it 14 thirds like that. Either way is okay. So when you do these multivariable equations, make sure you solve for the correct variable. Your goal, just like on all these other equation problems, is to solve and get the unknown value by itself, or the variable you're trying to solve for, get it by itself on one side or the other of the equation. You do that by using the addition rule and the multiplication division rule as many times as you need to get your variable isolated. And so as you see, these problems, they don't have just a single numerical answer to them. There's not one number value that you get for your unknown. There's a collection of numbers and variables. But that's okay. That's just the type of problem they are. Okay, well that's all for lesson 42.